Just go to my channel. My channel. Yeah, Andrew Butler. That's my name. Yeah, but it only records from the laptop. Huh? It does. It's just this is better quality. Is this working? Is it? Can you hear it?
Jonathan.
Hey! 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 It's an infinite loop! Are you happy with the 10-year delay? Those of you who are using Google Livestream, go into another room, okay? Okay. Can you turn off the volume, please? I'll leave it on, but I don't think there's any point to it. Okay, guys. We're going to do the stair script again. Did I upload the stair script? Was it there? Okay, let's go get it. Let's not waste... Let's go get the stair script. No, let's start it. Did we just do the YouTube? I didn't give you the script? Okay, we'll just start it from scratch. Because I didn't save it. So guys, we are going to use human. Because we're going to use the dynamic geometry pipeline. Everyone's got it, right? Those of you who weren't here last week, please go get it. Okay? I'm not going to tell you how because you should know already. And what we're going to do is we're going to draw more than one surface in Rhino. And we are going to draw that. When we draw that, we want to consider what layer we are drawing that on. So in this case, I'm drawing mine on the default layer. But for example, if you're working on your project, you might call it the stair layer, for example. Actually, let's do that. I'm going to rename mine stair. And then with human, we are going to go grab the dynamic geometry pipeline, and we are going to tell that to select from the stair layer we want surfaces. And the most important thing here is that we're drawing more than one, okay? Sure. This is streaming live on YouTube. Make sure if you like this video, like and please subscribe.
So bad.
And Squarespace, the perfect place to make a website. And have you considered reading a book recently? Well, I just don't have the time or day to pick up a book and like read it. But my commute, I've got plenty of time to listen to a book. Try listening to Audible. If you go to the link below, then you can get one free Audible book. I've been reading recently Captain Blood. It's really fun and exciting book. What? And also, for those of my Patreon subscribers, there's another link below for all the behind the scenes of this particular video. So if those of you want to get some extra information, get some extra tips, jump onto my Patreon page and off we go. Do you think I could actually make money doing this?
Yes.
Okay. Well, guess what? I am. You're paying me right now. Okay.
Quit your job at Cods. YouTube channel.
Okay, so we want to make sure there's more than 3. Cool. Yes. 2 is more. More than 1. 2 is more than 1, and so is 3. Yeah. Okay. Are we good, guys? Are we good? We're good. Now, the important thing about stairs is they're not travelators. They don't go flat. They rise, okay? But before I start lifting these up, we are going to do something to these flat surfaces just so that we know which way the stairs are oriented. So, we've literally done this already, so we are going to blast through it. We're going to go to divide surface. We are going to plug numbers into that divide surface. In one case, we want, let's just go 0 divided by 10. 0 is less than 10, not greater than. And in this case, we want the U direction to be 1, and the V count will be the number of stairs that we're drawing. Cool? So, and then with that should be, that actually might not be correct. Let me just double check. So if we polyline that, that's not what we want to do. But, unlike last week, unlike the week that we did this, can anyone think of a way to make the lines go in the direction that we do want them to go? Anyone? Monica? You're sitting in a dangerous position, Monica. You're framed. I can see your face. Think about it. What have we got? Tell me what you see. Yeah, we've got a 2-dimensional matrix, right? So what's one way that we can reorient the way that it thinks about data? Yeah, now there's one problem here. Actually, I've fucked up. Because flip matrix won't work. Because it's not actually 2-dimensional. So don't worry about that. What we want to do is change this to 7. And we want to change the V to 1. And that will fix the problem. There is a solution to that. The solution to that is a plugin. I'm the one? Why's that? Okay, I see. I wonder if I could pull off a YouTube channel doing this stuff. Yeah. My own YouTube, but I'd be competing against people like Archistar Academy and
I hate Archistar Academy.
and Parametric Monkey.
I think a professional employed at a firm currently that has industry experience and also teaches is kind of a bit more valuable perspective.
There are other people that have that same qualifications.
I get that, but have you seen the tutorials?
Yes, I have. I know they're shit.
Yeah.
They're shit. They are shit. They're shit.
You're going like, let's do
Huh? He's okay. We got it. This is being recorded. We're gonna get a lawsuit.
Who cares? What the fuck are we gonna do?
Okay, guys. Okay, so now we know which way these need to be oriented. Yeah, we need to basically pick the points of these 4-point surfaces and start pulling them up because they need to have some height to them to make them actual stairs. Okay. Whoop. Yep.
Okay, I'm gonna move, so how do you do that?
I'm selecting the surface. I'm turning on control points with this button here. I'm then selecting the 2 of the points and holding control as I drag them up.
Wait, how do you do control points?
You select the surface and then you click this button here. Show object control.
okay.
Or you can press F11? No, F10.
Actually, can you show us the symbol? Because it's cut off.
Yeah.
Sorry.
From my head.
No, it's like cut off on the screen.
Oh, what the fuck?
Yeah, that's what I'll tell you. It doesn't show up on the edge.
Maybe just redraw.
It is.
Okay, so what was it again?
This guy.
Oh, okay.
Now I'm going to write something in the side. Okay, so it's only 3 letters. You need at least 2. Oh, that looked like it was 3D, but it wasn't. You good? Okay, let's keep going. So we're using weave and dispatch and stuff like that, right? But just remember, guys, look at this. What have we got here? I want you to use panels. They're very useful. If you can't be bothered using panels, here's a little trick that no one's ever taught you. Maybe. I'm assuming. In Solution, no. In View, there is a little component here called Data Viewer. See, under View, Data Viewer. If you open Data Viewer up, and then turn on Auto Update, then if you click on a component's output, please, it will tell you exactly what a panel would tell you about the input or the output of that component. This would be,
Why does it do that pink thing so you know what you picked?
yeah. You literally answered your question. Why does it do that pink thing? So that it can tell you which one you clicked. Cool. Okay, so if we use Data Viewer or a panel, let's look at the topology of the data that we get.
Wait, how'd you get Data Viewer again?
View.
Oh my god.
Data Viewer.
Okay.
Look, you can make more than one. Flip. I never knew that. I've never had to do that. Yep. Bing. Ha 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 ha.
I love it. It's not like red. It's just like how long to your life.
No one's watching my YouTube videos.
Oh my god.
They're all named. They're named Code 1240 Week 5. Like no one's coming to them.
How do you make it go up the Z?
Okay, guys. If you're having trouble moving points in the Z direction, after turning on the control points, select the control points, hold control, and then drag them. And control will limit them to only drag in the Z direction. Okay, guys, what do we have? Let's look at the data, okay? What can you see, Louis, in this data? Is it too small? Yeah, that's probably why I need to use a panel. Blip. How many branches do we have, Louis? How many branches do we have? Right. Now, could some of those zeros be unnecessary? So what do we do to get rid of them? Simplify. So let's simplify it. Then what do we have? We can simplify, yeah, we'd simplify it. Now, I've right-clicked and used the simplify shortcut. Let's see if I can do this.
Hit me.
It didn't hit you. You were worried it was going to hit you, but it didn't.
Yeah, it did.
It didn't.
Yeah.
It bounced off you, did it? Serious? Are you serious? I'm sorry.
It's fine.
I didn't think I hit you.
Hi.
It didn't hit your eye. Okay, guys. After simplifying it, what do we have? We have one item in each branch, right? Now, we don't want that, right? Remember when we made the stairs the last time? We needed those lists to be almost like flat for them to weave together to create, like we moved it up and then we weaved it and we created a stair. And in this case, if I move up these lines using a transform, and we'll just use the default Z vector, and I then do a weave to bring them together, like so, we're going to get shit, right? That's not a stair, right? So what do we have? We have branches that are structured. If I scroll down and zoom in, if I scroll down, we will eventually get to 0, 5, 0, 6, 0, 7, then 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, and then 2, 0, 2, 1, 2, 3, 2, 4, etc. Can anyone guess what the first number relates to in that branch, in the tree? So, and this is why this thing's so cool. Whoop! Can we see, we can see 3 branches, right? Huh? You never knew? Yeah. We see 3 branches. What do you think this particular branch belongs to? Speak louder, Jonathan. The first surface. Okay, what do you think this branch belongs to? The second surface. And the third branch is the third surface, right? So these are relating to each surface. Now, if I want to remove one layer of branching without destroying all the branching, so for example, if I, well, no, I'm not going to do it. Do you remember literally less than an hour ago, maybe about an hour ago, I explained this. What component gets rid of one layer of branches? Either trim or shift path. Let's use shift path.
What is a plugin?
It's not a plugin. It's vanilla Grasshopper.
And the pink one.
It's also not a plugin.
Is it a plugin?
It's not a plugin. Oh, the pink one. The pink one. Do you want to know what that does?
No, I want to know what it came from.
It came from a plugin called. Oh no, the green one. The pink one is Grasshopper. The green one's not.
Right, okay.
It comes from a plugin called Tree Sloth. It's good. So we're going to use shift paths, okay? And if I just quickly shift my path from my polyline, we're going to let's see what that does to the tree structure. Ta-da! Right, we get 3 branches. And those 3 branches are specifically for each surface. So now if I look at the actual data, I've effectively clumped down each set of curve. Like if I just divide by 3, just to make it easier to sort of understand, or 4, we get 4 curves per surface, right? Does that make sense? This is probably the most important thing that I need you guys to understand for the rest of your careers. Okay? Is how this works.
I've never seen this. We might talk properly.
Okay? This is super important because now I can, when I run this through this system, we end up getting the stairs to work relative to each staircase, right? See now that we can move it and weave it, we're now weaving together like 2 lists of data that are structured properly. Does that make sense? That's all we had to do, shift the paths. No, blank faces. Michael, do you get it? You're a bit lost. Okay, let's start again. We have a polylines, right? If I want these polylines just to be in, like if I want them to loft together, what do I have to do for them to be able to loft? Like, these are not going to loft. So what would you do without, ignore shift paths, ignore the fact that shift paths is the correct answer. Just, I'm teaching the class, mate. Ignore shift paths is the correct answer. What would you have done last week if you had this problem? If you had a problem where you had polylines and you wanted to loft between them, and loft literally produces nothing. Why is that? Yes? Why is that?
Because there's no like points on the polyline across to it.
How many curves does a loft need to actually work? 2. And how many curves are in each branch? So it can't loft between 1 and 1. It has to need 2, right? So you would have probably flattened this list, yeah? Now if I flatten this right now, it's going to get rid of all the branch data. It's going to get rid of everything. And so, oops, no, we want to flatten that. So when we plug that into loft, what do we get? Right? A lot of you have probably had this issue, yeah? Have you had this issue? You have? Okay, so you would have gone, oh shit, I'm going to have to do each stair in its own script, yeah? You would have copied and pasted this script for each stair. We don't have to do that because all we need is for these curves to be in the same groups per stair. And fortunately, we've got them in a group per stair. It's the grouping of the tree. And so therefore, if we shift the tree, we remove the very top branch out of the equation. It's the equivalent of flattening that tree, but just one branch. Okay? So in doing so, we can now produce surfaces relative to each surface. We've literally created what we just made, right? So the benefit of that is we can then do functions like transforming the curves, such as moving them up, such as weaving them together, just like we did for a single stair, and then setting our loft to straight, and therefore making stairs. And in some cases it's not working, but I'll explain why. In this case, we'll probably have to do this. So we have the benefit now of the fact that we've got a geometry pipeline. So if I wanted to say make a stair over here, I've got a stair. Okay, so we good? This is probably the most simple I can explain this. Okay, so let's talk about a few things regarding stairs. Are stairs always going to have 4 treads or 3 treads? No. Sometimes we're going to have stairs with more treads, yeah? Like, for example, if I had a stair that did... this... The treads are shit, right? They're not doing anything proper, yeah? Okay, so we are going to start analyzing our script and actually produce values within it instead of using sliders, okay? Because actually there's a rule set that we can use for stairs. Like, we don't actually need to say, oh, my stair needs 10 treads. We can get the computer to work out how many treads a stair needs and produce that, okay? So, quick and easy way out of that one is if I pick the first point and the last point in a stair, I can get its height value, and from that we can work out how many treads it needs, okay? So, in this case, we have to do that prior to the divide surface occurring, yeah? Because the divide surface is effectively the thing that just decides how many treads there are. So, what is one way that we can find the height of a stair? Can anyone have a go? I know the easiest way, but I want to hear some of your suggestions. Okay. So if I walk away now, you guys would be fucked. You wouldn't know how to do stairs at all. Is that what you're telling me? You have no idea how to get the height of this object. No idea. You know how to get the length of the object? How do you get the length of it? Right. Okay. So what are points made up of? How do you construct a point? Okay, so that means, can you deconstruct a point to get its x, y, and z? So therefore, if you know the bottom point's z value and the top point's z value, would you know the height of the object? Look at that! Okay, now there's a cheats way out of that, and that's using this component here, bounding box. If we chuck all of these into a bounding box, and then we plug our bounding box into a deconstruct box, what that will do is that'll give us the Z domain of our object. Yeah? Which is literally the domain from where the object starts to the ends in the Z domain. Okay. We can deconstruct domains using deconstruct domain. We bring deconstruct domain in. What that's going to do is separate the start of that domain and the end of that domain. I really hope that this is pretty straightforward to a lot of you now. What am I going to do? I'm going to subtract the E value, I'm going to subtract the S value from E. Okay? If I go y minus x in an expression, that is going to give us the height of each stair. Is that guy playing Tetris? Or is he watching my YouTube video? What's his... He's not... Is he watching YouTube? Huh? Playing a game. Okay. Excellent. Nice to know that our careers are on the line here. Okay. Okay. So, we are going to assume that this is not to scale, right? We do not make stairs that are either 339 meters long or 339 millimeters long, right? This is not to scale. But what we're going to do is also, this is why I love expressions, because we want to find out how many treads and rises we need for our stair. What we're going to do is take the number that we've generated here, x minus y, and we're going to divide it by z. Z is going to be the height that we desire for our treads. So in this case, I'm going to say 1. But in reality, treads are really good at around 150 millimeters. Okay? That's a good one to remember. You don't want them to going too high or too low. Yeah. You mean like too shallow? So, what that's going to do is give us, it's probably going to give us a non-rounded number, right? It's not going to give us an integer, but what we'll do is rely on our divide surface component to solve that, to just round that for us. Now, something that's really important. I've got a list with 5 objects, right? And I've got a list with 5 numbers. Is that the correct data structure I need for divide to work? Do I need to do anything to this data? Is it correct? Do they match up? We don't have to do anything. Is that what you're saying? What do we need to do? Okay, speak up, speak up. Dude, you didn't speak up. You say what you are and I'll repeat it to everyone. Okay, so Jonathan says that this data is for only how many surfaces? 1 surface. And the others, there are other surfaces, but Jonathan's wrong. Okay? Because what we've actually got here, look, we've got 5 surfaces and we've got 5 numbers. Each number correlates to that surface, okay? So we don't actually have to do anything. It's perfect. We should be able to plug this into the U value. And clearly my number needs to be a little bit larger. I need to set that to 10. And what that will now do is produce treads for our stairs relative to the length or the height of the stair. Pardon? It's good. Okay, guys, just remember, the higher this number, the larger the steps are going to be. Okay? The smaller the number, the smaller the steps are going to be. And in this case, they're going to be really small. Yeah. Okay. You good? Monica. You good? How about this guy? You good? Everyone good? No, we're not there yet?
I don't know why it's doing that. Yeah, sure.
So small.
Yeah, I know, but it doesn't matter if I do it bigger or smaller. It won't do anything.
Ebony, you see where you can use this in your design?
Maybe I need to change it.
Okay. Next, we're going to take some more steps, okay? We're going to take some more steps.
Just a quick question.
Yeah.
If the incline is going the other way instead of the way that you're...
Just lift that one up.
And, so I always...
There is a way to get it to test
Yeah,
which way to go,
yeah.
but we're not going to do that today.
Okay.
We good? We good? Okay. Time to add another surface. This time, I'm going to draw one that looks like this. I'm going to draw a curve. I'm going to move it. I'm going to copy and move it. And I'm going to move it up. And then I'm going to use loft in Rhino to loft between those two curves. We have a problem. Yes, they're not. We're going to make them curved. So what is the issue? Yava, what's the issue? Yeah, so what we're doing, guys, let's just look at the process that we've taken. We've taken a surface, we've divided it by 1 in one direction, which is just going to give us the endpoints along the surface, yeah? So if I amp up this number, yeah, what that's going to do is our polyline's going to end up following that curve, yeah? But what if we don't want it to be a polyline? What if we want it to be something else, like a spline? All we have to do is swap our polyline for the interpolated spline curve, right? And it should satisfy the curve of the surface, producing a stair that should look Come on, stair. A stair like so. Cool? Now, the reason that works is because as we divide our surfaces, if we had this set to 1, remember how we had 2 points in there? And therefore, if you put a polyline between 2 points, it creates a line. The more points that we divide by, the more points per group we're going to produce. But no matter what, once we run it through the process of creating an interpolated spline or a polyline, we should still only end up with 1 curve per branch. So when that gets shifted with the shift paths, that will then move and weave into this loft. Okay? Line-like curves are just lines, and planar curves are not just lines. They're a curve, but they sit on a plane. They're planar.
I still can't get it right.
Do you know what a plane is? No, line-like curves sit on multiple planes. Think about it. How many planes does a line exist on? Infinite. Yeah? Why only 2? Why only 3? No. I have a line. I can draw a plane off of that like so, yeah? And I can draw a plane off of it like so, and like so, and like so, and like so, and like so, right? But a planar curve, I can't change it. It only has one plane. Polyline where every point of the polyline is on a plane, yes, it would be a planar curve. But that polyline is not planar. It's a cube. It is planar, it's drawn on a flat plane. But you know what I mean. Yeah? Woo! Huh?
How do I fix this?
I just explained how you fix that. Were you listening?
Yes, well, it didn't work.
Look. The number you divide this by, when it's set to 1, it's only going to divide it by 1 in one direction.
Oh, okay.
But as you add that up,
Yeah, okay. Okay.
suddenly everyone starts producing rococo grand staircases into their cinemas with the curvatures.
It would have made the stairs a lot easier. Instead of just doing it as a series of duplications.
We good? What is he saying about me? What's he saying? He's talking smack. Huh? What about it, Louis? What's the matter?
Don't worry about it. It's just
You say that all you did was assign the way you would have assigned the other staircase.
If you loft that, right?
Yeah.
What does loft produce?
Gives it depth.
No. What type of geometry does loft create? Okay, we've got points.
Yeah.
I got a point. If I make 2 points and I connect them, right?
Yeah.
What type of geometry is that?
This is the line.
Right.
Yeah.
Okay. If I had 2 lines
Uh-huh.
and I put infinite lines in between, effectively connecting it like loft, what do I create?
A rectangle. Or square. Flat surface.
A surface.
Okay.
So what does loft produce?
Surface.
And what are we trying to pick up with humans? Dynamic geometry pipeline.
The line.
No. Read.
Oh, a stair.
A stair, but what else? What type of geometry are you trying to pick up? Surfaces. So what do lofts make?
Surface.
And so therefore, when we loft between these 2 curves, what do we produce?
Oh gosh. Are we loft? Say it again.
When we loft between these 2 curves,
Yes.
what have we just produced?
Surface.
So therefore, human
Yeah.
is going to pick that up as a surface and put a stair on it. Would you guys agree
Yes.
that this type of class format is still important in this degree?
Yeah.
Yes.
You gotta be working together.
I think it should still be important all the way to the end.
You good? Okay. What I would like you guys to do for at least the next 30 minutes, at least, I want you to think about how this could apply to something in your design. Other than a staircase.
Franklin, I need to get that. His script is like matching It's lofting between the two surfaces.
We've all been
Just think about it, okay? I want you to have a think, and then try. Have a go at it. Have a go. Basically, if you've got somewhere in your script that you are copying and pasting your script to repeat a process, you probably can do that without using these techniques. Okay? I'm going to stop recording and stop streaming.
Would it be possible if you do actually show us how to do that test? Because it's driving me nuts.
Just flip the direction. Like, instead of picking the second curve, the first curve first and the second curve second, pick the second curve first. And the first curve second.